Myself, Professor Dhananjay Gujarathi. Today we will discuss the device ultrasonic interferometer to determine the velocity of ultrasonic sound through the liquid and adiabatic compressibility of a given liquid. I will share the screen to explain the details about this experiment. Now, this lecture contains the aim of the experiment, the apparatus which are to be the use, the theory of ultrasonic sound wave and interferometer, the procedure to perform the experiment, and simulators with results. Our aim is to determine the velocity of ultrasonic sound wave through a different liquid media and to calculate the adiabatic compressibility of a given liquid. The apparatus which are to be the use as the ultrasonic interferometer, there are many sample liquids are there, high frequency generator and etc. Now what exactly the sound wave and the ultrasonic sound wave? Now as such a theory it is to be the concern. The sound wave is a vibration that is transmitted through a medium such as air, water and metals. Ultrasonic wave is defined as inaudible sound with a frequency for human being, the frequency of which generally exceeds 20 kilohertz. The animals like dolphins and bats on that of the ultrasonic sound wave to live. From the time interval between the transmitted sound and the echo received, as well as the angle of that of the echo received, they can find the distance and the position of the target. Now, what are the properties of the ultrasonic waves? There are many properties of ultrasonic waves. Out of these, some of the properties are: first, the frequency is always greater than that of the 20 kilohertz. I have already explained. Smaller the wavelength, so that their penetrating power it is to be high. Next, it cannot travel through the vacuum. It travels with the speed of a sound and maximum velocity in a denser medium. In homogeneous medium, it travels with a constant velocity. In a viscosity liquid, ultrasonic waves they are produce the vibration. They undergoes reflection, refraction, absorption. They produce the intense heat when they pass through the object. Obviously, it is a longitudinal type of the wave. Now, ultrasonic interferometer, it is a simple device which yields the accurate data from which one can determine the parameter like a compressibility of a liquid. Now, how this ultrasonic sound wave it is to be represented as a longitudinal wave? It is like this. Now, ultrasonic sound wave is a longitudinal type of the wave. This is the longitudinal type of this wave. It propagated through the medium. The molecules in this medium, they are vibrated like this over a very short distance in the direction parallel to the longitudinal wave. During this vibration, momentum it is to be the transfer among the molecules so that the wave it is to be the propagated. Now, in this experiment, the stationary wave which are to be the produced. Then, what exactly the stationary wave is? Stationary wave or the standing wave, they are produced by the superposition of two progressive waves of a equal amplitude and frequency, but they are traveling with the same speed in opposite direction. What exactly it means? This is a ultrasonic wave which is to be the produced with the help of this crystal plate. and it is moving in the positive x-axis. Then it is reflected back from this plate with the same amplitude, with the same frequency, with the same speed, but in the opposite direction. Hence, such a standing wave which are to be the produces between these two plates. The node it is to be obtained at the end like this, and antinodes are here. Again there is node, again there is antinode. That is the alternate node and antinodes which are to be the present within this two plate. Now what exactly is the node? This node is a point along a standing wave, has a minimum amplitude, and antinodes has a maximum amplitude. Then how one can produce such a type of the ultrasonic sound wave? Now it can be produced by the different method, by using the mechanical generator, by using the piezoelectrical, by using the magnetostriction. But in this ultrasonic interferometer, the waves are produced using the piezoelectric generator. Then what exactly the piezoelectric generator? This is the most common method used for the production of ultrasound. When a crystal is subjected, this is a crystal, if it is to be subjected to an electrical field, then the crystal it is to be the contract or the expand, which causes a piezoelectric crystal to vibrate mechanically. And in this way, by using the quartz crystal, this ultrasonic waves which are to be the produced. Now, what exactly, how this ultrasonic interferometer, it is to be the same. Now, this is our ultrasonic interferometer. Now, in this ultrasonic interferometers, the ultrasonic waves are produced by this quartz crystal by using the piezoelectric effect. Now, the liquid medium whose compressibility is to be find out, which is a place between this one plate and this is the quartz crystal, that is the reflector and the quartz crystal. And the standing wave which are to be the produced, that is a standing longitudinal wave which are to be the produced. And so that at the end nodes are there, and in between alternate antinode nodes are there. There is a movable micrometer. This is a micrometer, and the reflector or the movable another metallic plate parallel to this quartz crystal, which reflect back and produce a standing wave. The wave interfere with a reflection, and if the separation between two or the successive plates is exactly, that means this and this distance is exactly half the integral of the wavelength of that of the sound, then standing waves which are to be produced in the liquid. Under these circumstances, acoustic resonance occurs, and the resonance waves are maximum in amplitude, causing a corresponding maxima in the anode current, which is to be measured. And hence, separation between the successive adjacent maxima is lambda by 2. It is to be the lambda by 2. Now, how one can perform actual experiment? Now, in the actual experiment, first we have to find out the least count of this micrometer rod. Now, this is a main scale. This is nothing but our vernier scale. Now, in the main scale, see here, it is 0 to 5. There are the 10 divisions are there. Therefore, the least count is nothing but the smallest division, the value of the smallest division on main scale plus, that means value of the smallest division on main scale divided by total number of division on a vernier scale. Now here it is a 5 millimeter divided by 10, that is a 0.5 millimeter. It is nothing but the value of smallest division on that of the main scale divided by total 50 divisions are there, and hence the least count is 0.01 millimeter. Now to perform this experiment, there are the formula. Obviously the velocity v is equal to lambda times f. We are familiar with this. Now what exactly is lambda? The d, that means a separation between the two successive adjacent maxima. And this d is equal to half the integral of the wavelength. That means d is equal to lambda by 2. Therefore lambda is equal to 2d. And hence v is equal to 2 times d times the f. Now, how one can find out the adiabatic compressibility? The adiabatic compressibility beta is equal to 1 upon rho into v square, where rho is the density of liquid and v is the velocity. Now, here, see here, in this photograph, here our quartz crystal is there and the liquid which is the pour in this pipe, like this. Then this is a reflector. Place the reflector, that means this rod, and tight it like this. Actual setup, the complete setup, it is to be like this. This is our ultrasonic interferometer, and here with the help of this knob one can adjust the frequency of this generator, and with the help of this pointer we are measuring the current. With the help of this virtual lab we perform this experiment like this. Now see here, this is our ultrasonic interferometer, and this is the instrument which generate the frequency and measuring the maxima or minima of current, that is anode current. And this is micrometer screw gauge. Okay. Now, here we choose the medium. The medium may be water, acetone, kerosene, castor oil or glycerin, like this. For example, we select the glycerin, then select the frequency of wave as a 4 megahertz, then show the graph. Now see here. Okay. Now in this case, adjust the gain, that means adjust this pointer for that of the minima, and with the help of adjustment adjust the reading for that of the maxima. And hence power on this, then adjust the gain to that of the 40 microampere, actually it is in microampere, and the adjustment for that of the maxima anode current, assume that it is to be the 80 microampere. Now start this experiment and move this micrometer like this in that of the anti-clockwise direction, so that the rod it is to be the move in a downward direction, sorry, in upward direction. Then we get here the current and we obtain the current as a maxima, that means maximum current. Okay, see here, this is to be the maximum current. Then note down this reading. Okay, with the help of this is the main scale and this is the vernier scale. And note down that reading as N1. Then again move, then we get a minima again. And after some time, there is a second node, that is antinode, which is to be obtained. Because the antinode is nothing but the maximum current or maximum amplitude. Now the see here is the another antinode. Now the pointer it is to be the move. Then slowly it is to be the move to get a maxima current or anode current in this instrument. Okay, and note down this reading. Now see here in this reading, actually this is a 0.5 millimeter, then this is a 1 millimeter, and there is a fifth division which is to be the coincide. Then reading it is a 0.15 millimeter like this. Then again obtain the third node or third maxima. Then there is a fourth maxima, there is a fifth maxima like this. And continue, you should take the number of reading. Now see here, the third antinode which is to be the obtained, that is third maxima which is to be the obtained like this. Again we get the minimum and so on. Now as a result, if you see the result, then whatever the velocity which is to be the obtained, it is a 1260 meter per second, and adiabatic compressibility is a 21 into 10 to the minus 10 meter square per Newton. Okay. Now, how to write down the observation table and how to do the calculation. Now see here. This is the first part to find out the least count of micrometer. Then there is a second part, how to take the total reading. That is, the total reading is equal to main scale reading plus vernier scale reading multiplied by least count. For example, main scale reading is a 16 millimeter plus 23rd line which is to be the coincide of that of the vernier on that of the main scale. Then total reading which is to be the obtained is a 16.23 millimeter. Now the next is the liquid, it is to be the taken as a glycerin. Density of glycerin is 1520 kg per meter cube. Frequency applied voltage, frequency of an applied voltage is 4 megahertz. Then observation table, it is like this. The micrometer reading, that is the maximum micrometer reading as N1, N2, N3, and the difference between the consecutive maxima, that is N2 minus N1, N3 minus N2 like this, and the mean D, that is the separation between the two consecutive maxima, which is to be obtained as a 0.15 millimeter. Now we know that the velocity V is equal to 2 times D times F. This D is a mean or average value. We put here in meter, then 4 into 10 to the 6 hertz, and substituting all this value, we get the velocity as a 1200 meter per second. Now for adiabatic compressibility, beta is equal to 1 upon rho V square. Substituting all this value, we get 4.62 into 10 to the minus 10 meters square per Newton. And hence, we can write down here as a result.